Hi, I'm Becky and my teammate is Chris Wu. We're going to talk about our project. So for this project, we want to develop a deep learning project that can recognize the emotional expression on people's faces. This is inspired by other basic projects like facial recognition, mask recognition, and cat and dog recognition. After we learned about this project, we wondered if we could build a program that is more specific and more into people's daily lives. So we're going to talk about the background. Facial expression recognition is an important area of research in computer vision and artificial intelligence. The aim of this field is to develop algorithms and techniques that enable machines to detect and interpret human emotions from facial expressions. The process of facial expression recognition involves several steps, including face detection, feature extraction, and emotion classification. In face detection, the algorithm identifies the face region with an image or video. In feature extraction, the algorithm extracts relevant features from the face region, such as the position and the shape of facial landmarks, which can be used to infer emotional states. Finally, in emotion classification, the algorithm assigns an emotion label to the face based on the extract feature and a predefined set of emotions. Several approaches have been proposed for facial expression recognition, including traditional machine learning algorithms such as support vector machines and neural networks, as well as deep learning techniques such as convolutional neural networks and recurrent neural networks. These approaches have shown promising results in recognizing a wide range of emotions, including happiness, sadness, anger, fear, disgust, and surprise. And now we're going to talk about the future applications. So for the future application, there are several fields we can talk about. So for example, in mental health diagnosis and treatment, emotion detection can help mental health professionals to diagnose and treat emotional disorders more accurately. For instance, it can be used to detect symptoms of depression, anxiety, or other emotional disorder in patients and provide them with personalized treatment. Also, there are other fields such as customer service, education, market research, human research, security, emotion, and gaming. Now we'll pass to Chris to talk about the code.
Yeah, let me talk about the code. So yeah, here is our core code for building the mini VGGNet model. You can just take a look. So as one of the convolutional neural network, the mini VGG net can improve the performance by using multiple layers. And here is our accuracy we get, and the overall accuracy is about 0.66. Okay, yeah, so now let me explain the model in more detail. So we use the mini VGG net with multiple layers that can extract features from the input images. We also train the model using the atom optimizer and cross entropy loss function. We trained the model on the FIR 2013 dataset. And to explain the model in more detail, let me explain the layers. So first we use the input layer of 48 times 48 pixels. We use 3 convolutional layers. And we have one dropout layer, which is to prevent overfitting. We also have a flattened layer. It is used to flatten the convolutional layer into a one-dimensional array. We also have the fully connected layers and the output layer. So here are the layers we use. During training, the model is fed batches of grayscale images of size 48 times 48 pixels, and the optimizer adjusts the weights of the neuron in each layer to minimize the loss function. After training, the model can be used to classify emotions from new images. And as a conclusion, based on the results, the trained mini VGGNet model achieved an accuracy of around 0.66 on the test set of the data set. So this accuracy score might not be as high as desired. It is important to note that the emotion can be really difficult to quantify and classify, even for us humans. And also our dataset has some limitations. For example, all the images were captured in the lab and only has the front facial expression. Also, our dataset is very small, so in the future, we can improve it by using data augmentation and hyperparameter tuning. And yeah, despite these limitations, we still get a very promising result and demonstrate the potential of the deep learning for emotion detection. The trained model was able to accurately classify emotions from new images in real time, which could have practical applications in fields such as mental health, gaming, and marketing. Yeah, thank you for listening to our projects.
Thank you.